Okay, good morning, everyone. I'm Xinzhang from Fudan University. Now I'm honored to present our work, an empirical study of fingerprint API misuse with lifecycle analysis in real-world Android apps. This paper focuses on fingerprint-based authentication, or FpAuth for short. As a widely used technology, it is integrated in all kinds of mobile apps. Also, it is widely used in some sensitive scenarios, such as using FpAuth to log in into account, unlocking apps, and making payments. While it brings convenience for us, it also comes with some high security demands. So, when we perform FpAuth, what exactly happens in our phones and apps? The process starts with the user's fingerprint being scanned by the sensor. This fingerprint data is then compiled securely in TEE, which is an isolated, secure environment within the device. Then it gives the verification result to the app through the Android's fingerprint APIs. In this process, cryptographic keys can be combined into this process to ensure the integrity of the verification result. Then, for developers, implementing FpAuth requires using Android's fingerprint APIs. However, these APIs are complex, spanning 5 function groups, and have evolved significantly over the years with major version changes. As a result, this complexity often leads to misuse by developers, which result in some serious security issues. To study these issues, we take a new perspective, analyzing FpAuth from the lifecycle. We found that FpAuth actually consists of 4 key stages: activation within the app, verification, and fingerprint updates and deactivation. Previous research had mainly focused on the verification stage, and our study systematically examines the entire lifecycle, uncovering new security issues in the often overlooked stages. In total, our paper studies 4 types of fingerprint API misuses. The first 2 was partially explored by previous work concerning the verification stage, and the other 2 are newly proposed by us. Then I will introduce them one by one. The first misuse, obsolete API usage, considers a local software-level attacker, such as a local malicious app or SDK. The work feedjacking in NDSS 2022 shows that using the obsolete FpAPI will make the app vulnerable to UI attack, hijacking the fingerprint. And the second one, inadequate cryptographic validation, targets a local OS-level attacker with root privilege. It was first proposed by a great work, Broken Fingers, in NDSS 2018, which shows that failing to correctly bind crypto will result in unreliable verification results. And our work will measure the current misuse state and provide some insights. Let's zoom into the third one. Imagine a physical curious attacker who can briefly access the victim's unlocked device. Usually, apps need to authenticate the user when they deactivate the FpAuth protection. However, if the app doesn't require authentication, the attacker can disable protection permanently, allowing unauthorized access. We'll give an example later. The fourth one is about updating fingerprints on the device. When the user add or remove their fingerprints, they are required to input their login screen PIN. A securely implemented app should detect these changes and invalidate the FpAuth to prevent unauthorized access. However, this misuse will make the app vulnerable to recognize fingerprint updates and bypass the authentication. It will degrade the security model from 2-factor protection namely fingerprints plus PIN, to just one weak factor, namely PIN, significantly weakening security. This misuse considers an attacker who knows the victim's login PIN. However, PIN is weak. They are vulnerable to shooter surfing, guest attacking, and some social engineering, and so on. Let's see an attack scenario. The victim's phone is stolen by a thief with a sensitive app installed on it. Once the thief gets the locking PIN of the victim, they can add their own fingerprints or remove all existing ones. At this time, the thief can bypass fingerprint authentication in the app to make payments and steal the victim's money. Then, to automatically detect these misuses, we built a static analysis tool including 3 main steps. First, we noticed some apps may have different intentions when they implement FpAuth, so we distinguish them and take into consideration when identify misuses. Please refer to our paper for more details about our tools. And the second phase is we identify key stages in the FpAuth process, including deactivation and fingerprint updates, by analyzing relevant UI components and API calls. Finally, we use static analysis to map the app's code against 7 predefined misuse patterns and identify misuses instances. To measure the FpAPI misuses in real-world apps, we perform analysis on a total of about 65,000 apps from Google Play and Huawei market. Among them, we identified 1,333 apps using FpAuth. These apps belong to sensitive categories and have a combined total of 280 billion installations, showing their widespread influence. And our results are concerning. Almost all FpAuth apps, about 97%, contains at least one type of misuse, and each type of misuse is present in nearly or over half of the FpAuth app. Let's look at some specific findings. For obsolete API usage, even 5 years after the release of the more secure FpAPI, nearly half of the apps still only use the unsecure old API, which make them vulnerable to attack. And regarding unauthorized fingerprint deactivation, we found 120 apps enforce authentication when activating FpAuth, but fail to do so when deactivating it. This makes the protection ineffective. For example, in WhatsApp, it requires FpAuth when activating fingerprint lock, and it needs re-authenticate every time returning from background. However, if someone has the opportunity to turn off the fingerprint lock, since authentication is not required when deactivating it, they can then obtain permanent access. And for the last one, mishandled fingerprint updates, it's directly related to 2 APIs. The first one, set user authentication required, makes crypto bond with FpAuth. Then we can use the crypto to validate the FpAPI results. FpAuth results, sorry. The second one configures whether to invalidate the crypto when fingerprints are updated. There are some interesting findings here. Some developers seem to prioritize functionality over security. For instance, 17 apps that don't allow PIN as an alternative, but they deliberately ignore fingerprint updates. And 5 apps show a lack of security knowledge. They set invalidating when updating fingerprints, but nullify this security intention by misconfiguring the other API. We have responsibly reported these issues to vulnerability database and developers and received 184 CVE IDs and still none. In conclusion, our study provides a comprehensive analysis from the FpAuth lifecycle perspective. We identified new threat models and 4 common FpAPI misuse types. Our static analysis tool can effectively detect these misuse, and the large-scale measurement on real-world apps showed the serial security issues, highlighting the need for developers to enhance their understanding and secure usage of FpAPIs. Thank you all for listening. I'm happy to take any questions.
Let's thank our speaker. Questions from the audience? No? Don't make me go to ChatGPT. Please, yeah, introduce yourself.
Hi, I'm a researcher from University of Texas at San Antonio. Yeah, very interesting work. Do you just look into the fingerprint ID, the API or fingerprint, or do you think maybe we can extend it to, misuse Face ID?
Okay, actually, these Android fingerprint API, in their official guides, they claim they support Face ID. However, at this time, it's usually used in biometrics such as fingerprint, but not well used in Face ID. Yeah, but I think it's the same principle.
Cool. Thank you.
And one more over there.
Hi, I'm CEO Chao from the Chinese University of Hong Kong. So I have 2 questions about this research. So first is, I was wondering if the app developers, what kind of feedback did they give you when you tell them that you found these kind of misuses? I'm asking because it seems to me that some app developers might have very different assumptions when they implement this fingerprint deactivation feature. Say, for example, right, for WhatsApp, when the phone is already unlocked, I don't quite understand why it's necessary to do the fingerprint authentication again. So it seems to me that the developers might have a very different understanding and assumption there. And then my second question is, according to your research, what would be the right thing to do when the app developers are trying to implement these fingerprinting kind of authentication and deactivation features? So according to your claims, pins are not okay, pins are misuses, but I can also argue that, well, fingerprint itself is a misuse, so I can also cut your finger if I really want. So what is the right thing to do there?
Okay, the first question is about the developer's feedback, or yes?
Yes, correct.
Yeah. Actually, we reported to many developers, and some of them actually they think the PIN is enough. They believe the fingerprint is not stronger than PIN. Actually, in some standards, they believe the fingerprint is bound with the person itself, and the PIN is not. So fingerprint actually is a stronger factor than the PIN. So we believe this misuse will weaken the security. And
so the second question is, what is the right thing to do? If I'm a developer, after I see your research, what should I do? Okay.
Yeah, actually, in our paper, we provide best practice to implement FpAuth securely, such as we can use the cryptographic key in some special intentions, such as using FpAuth to log in or to make payments. We should combine with cryptographic key to validate the verification result and to validate when the fingerprint updates. And the specific API usage we already illustrated in our paper. You can refer it to for more details.
Okay, thank you. I'll read your paper. Thank you.
Okay.
I think we have time for just one quick one.
You have asked just now you said that the application allows the users to add the fingerprint by themselves. So I want to know whether it is a custom fingerprint API or is the system API. Because like if you are using the system API, you should not be able to add any fingerprints you want, right?
Yeah. Our study focused on the system fingerprint API, and the fingerprint updating is on the device.
Oh, okay, thank you.
Okay, let's thank our speaker one more time.
Okay. Thank you.